My name is Caitlin Murphy. I'm from Bangor, Maine. I'm working on a master's degree in biomedical engineering and theoretically, hopefully, graduating in December. I did my undergraduate work in chemistry. So I was working over in Aubert, and I did some research over in Aubert before transferring over here into the biomedical engineering department. Maine's my home. I mean, I grew up in Bangor, Maine. I did my undergrad here, so I fell in love with UMaine in my undergrad. And then I was talking to Dr. Bowie, and who's one of the associate professor in this department, and he just got me really excited about biomedical engineering. So I looked into what the graduate programs are and fell in love with the project I'm currently working on. So Perkinsus marinus is a single-celled organism that eats oysters, and we're trying to upscale its growth from small scale to larger scale via bioreactor fermentation, because Perkinsus is a close relative of Plasmodium, and that Plasmodium causes malaria, and they want to be able to genetically modify Perkinsus with Plasmodium genes in order to turn Perkinsus into an oral vaccine for humans. This whole thing is called the DAS-skip system, so they're a bioreactor. So what's happening is I put in my medium and my cells into this big reactor, and then I let them sit, and then they grow. And while they're growing, I'm measuring the pH of the system, because if the pH gets too high, then the cells don't get happy. I'm measuring the redox of the whole thing, which is essentially telling me if there's oxygen present in my medium, because if they don't get oxygen, they don't like to grow, and they get real unhappy. And then I'm measuring the temperature, because if they're not growing at the correct temperature, then they're not gonna grow. So if it's too cold, they're gonna go into survival mode, and if it's too hot, they're gonna die. So we are looking at, looks like it's just broth, but in this broth there are, if you look under the microscope, when I measured it the other day, the OD was, the optical density was about 0.8, so that translates to about 5 million cells per mil. UMaine feels like home. Everyone here is always so welcoming and so nice. It just feels like home.